Hi, all. So just a quick question here, and I figured I'll just start with a poll. How many people have used ChatGPT for something that they thought was actually valuable to them? So not just use ChatGPT, right? So a decent number of people are finding value from ChatGPT. So that's a good sort of sign. In terms of a disclaimer, Progress is a company that makes AI systems better, faster, more accurate, cheaper, trustworthy, responsible. We don't actually build the AI systems, and we'll be talking about a decent number of these AI systems. So that's really what this disclaimer is all about. So imagine you've found a use case in your company. The business has approved it because the ROI seems to be worthwhile to do, and you're ready to start this project. You're ready to get going, and you're excited about it, and you have the funding, and it's off to the races, right? Well, not quite. Rockets tend to blow up every now and then if you don't think of all of the things that might go wrong. So this quote is from Gartner. At least 30% of the projects between now and the end of 2025 are not going to go into production. They're not saying they're going to be they're going to fail totally, but they're going to be abandoned. Honestly, if you ask me, I think this number is low. I think they're just being very conservative about their prediction. I suspect, I think it's going to be more like 50%. But here's the deal. Why? Well, poor data quality. And at dinner last night, we had another sort of maxim that came up, which is you are what you eat. In sort of the GenAI space, the GenAI is only good as the data you feed it. So it's pretty much the same stuff, right? What goes in had better be good and valuable. Otherwise, the answers are not going to be good and valuable, right? Inadequate risk controls. Generative AI systems bring a whole new set of probabilistic failure modes that you have to take account of. And so understanding what those failures are, how they exist, how you can correct for them is really important. Costs are another really interesting issue. 2 or 3 months ago, when OpenAI introduced text embedding 3 large models, I did a back of the napkin calculation, and for 4 or 5 terabytes to create embeddings for those, it would take about $130,000, right? So that's not a lot of data, and yet still a lot of cost, and you're not doing that just once. Every time you update the data, you're going to have to incur those costs and things like that, right? So those are important. All 3 of those things lead to unclear business value in general, but the way I always recommend to all of the customers I'm talking to is you have to have your use case and your ROI in mind before you start, right? If you don't have those 2 things locked down and understood and characterized, you're setting yourself up for potential risks and failures. So we've been working on what we call semantic RAG or multi-RAG, and I just heard another name for it, omni-RAG, which is basically use all the tools in your tool belt to find the right quality controlled best data you can, deliver it to the GenAI to then get your answers, right? So, and if you do that, if you're not just saying, hey, I'm just going to use this kind of RAG or that kind of RAG, I'm just going to use all the tools in my tool belt to find the right data, to curate the right data, to get the right data, then you can get a lot of benefits out of it. You can get accurate answers. We literally just completed a POC where a customer asked 200 odd questions of their test data set, and every single one was correct and complete. Correctness is one thing, but completeness is another, right? So being able to get both of those. So if you calculate that into a percentage, that's 99.5+% accuracy, right? And you can reach those numbers, but you have to know your use case. You have to know your use case. You have to understand the semantics. You have to understand the model. And you put those things together, and you can reach super high levels of accuracy. And that's literally just one example. As we go through this, we'll go through some other ones. Cost, as we already talked about, is important. Being able to reduce costs an order of magnitude. Who's not for that sort of capability? And then in terms of adaptability and compliance and things like that, if you're keeping track of all of the information you're feeding the GenAI and being able to record its answers, then you have a lot more capability to prove out this is why these answers were made. This is why the human reviewed this and made a decision on this basis. So the ability to have a platform that enables you to do those kinds of things and reduce your risks in those spaces is something that people should very seriously consider. So we talked a little bit about sort of the risks, and we'll now sort of formally do this. You probably heard, if you're here at the keynote, you probably have seen this slide. I'm not going to talk about the risks. I'm going to talk about how to solve for these risks, right? And what we have realized in all of our sort of year and a half of testing with our customers is that the context is really, really the king in terms of helping solve for these risks. So generative AI systems have these token windows, right? So what you feed into the token window could be a prompt in a chat, but it could be your private data that is relevant to the prompt that was put into the chat as well, right? So if you have a question and you retrieve the right, correct, fit for use, fit for purpose, relevant data and feed it to the GenAI and then say, now answer the question, it's going to answer very differently from if you just ask it the question, right? So by giving it good data, you will get much better answers. So that helps reduce hallucinations. Even if the GenAI system was trained on biased data, if you give it unbiased data in the prompt, you now are focusing it on unbiased data sets and are able to get less bias out of the system. From an understanding perspective, we found this really interesting. Biju, when we first tried to say, you know, this concept has these 10 different names, and we gave it a graph and said, hey, here's a graph. It was having a hard time figuring out that what the graph was and why it was synonyms. But when we gave it the graph and we gave it an example of here's how to use the graph to figure out that these are synonyms, and we wrote that all out, it started understanding, oh, now I know how to use this graph for synonyms. So logic and understanding, if you give it enough examples, even if you do it in a real-time basis, it does much better at it than if you just throw something at it. Data cutoffs, up-to-date real-time data is very important. In fact, some of our customers are saying, Imran, I actually don't want to feed it the older data. It's now out of date. It's going to give me an out-of-date answer if I feed it the older data, right? So that becomes an important thing. On the explainability side, when we construct our systems, we always give it that referential data. We always ask for the answer. We always record both things. In fact, we have the ability to have the end users record whether they like it or not. So not only are we getting sort of the GenAI to do stuff, but we're also recording whether it was useful or not, right? And that was why my first poll was about whether it was useful or not, right? Because I've had lots of cases where I use ChatGPT and I'm like, that is a totally bogus answer. Not very useful. I'm wasting my time here, right? And at other times I'm like, okay, I'll limit the scope. I'll get it down to exactly what I need. I'll give it the right data and then boom, I get a good answer out of it, right? So knowing how to use these systems to make it most useful for yourself is extremely important, and the context is really the key for that as well. On the robustness side, if you allow it to answer whatever it wants to answer and open it up to the world, you tend to get all of these other things that are happening on the left of that bullet. But on the other hand, if you say, hey, here's the data, I want you to use only this data because I'm focusing your application or your use case on this data set, then you tend to get much more reliability and much more accuracy out of it and less ability for people to hack and attack it. Not that that's not going to happen, because it will, but just a lower ability. So for those of you who haven't seen this slide set, what do you think is the background behind context is king? I'd like somebody to raise their hand and take a guess at it. And there's no wrong answer, actually.
you're not necessarily taking in the right piece of data that makes it that answer.
Mm-hmm.
So it's like, so if they had like a difference between a wolf and like something else for the example, but the reason why I was able to tell a difference between the wolf and the other thing wasn't because of the features of the wolf. It was because of the snow
Yes.
for the example.
Yes, I've seen that machine learning example. Yes.
So that's what I think. I'm also not a technical person, so I could be completely wrong.
So you're what are you saying about the background here?
I think you have to feed it that right data so that the model can understand the context of why it is what it is.
You're totally right about that. I'm actually asking about the picture behind the word context is king. So what do you think the picture is?
Oh, I don't know.
Take a guess. Take a guess. What does it look like from the small context
like
you have? It's
like
a puzzle, right? So that's a good answer, and most of the time people answer that. If you see this full context, now what is the picture?
A puzzle.
It was the throne, actually. I only flashed it up for a few seconds, but it was a throne, like a Game of Thrones type throne, like a play on the word king.
Oh.
All good, but you know that's context, right? That's context, and that's an example of having a very narrow context versus a bigger picture, right? So that's all that was about. So this was also a really interesting quote. Forbes said that, hey, this is not the year of AI. This is the year of knowing how to use your proprietary data sets, because that's really what's going to give you the competitive advantage for your mission or for your goal or for your business, however you want to define that. So we rapidly iterated through 3 different architectures when we started testing early last year. And by March, we had sort of honed in on what is really working. And so now it's just been a matter of refining and improving that. And so we'll talk about those 3 architectures, and then Biju will give you a demo of this system as well. So let's go in. First architecture, just straight out of the box. Let's start asking ChatGPT some questions, or let's ask Anthropic some questions, right? And I akin this to a closed book exam. Basically, what you've got going on here is, the system has spent 1.5 years learning about the world and has its level of understanding of sort of the digital world that it lives in. And it'll try to answer the best it can from that data, right? So you ask it a question, you get the answer, and you have all those things we just talked about in the previous slide in terms of problems. And, it doesn't take advantage of your proprietary data, right? Which is really, if you're a company, you have lots of proprietary data that is inside your company. Or if you're a public sector organization, you have lots of private data that needs to stay private because of laws and compliance and things like that. But that data could totally be used to solve a functional or business problem that the end user would benefit from, right? So then the next question was, okay, how do we take advantage of that data? Well, the MarkLogic component of our Progress Data platform lets you bring in any kind of data really, really rapidly, lets you curate that data, lets you quality control that data, lets you make data from different sources look like the same kind of data. Simple thing about a patient record that has 0, 1, 2 in the source database, but you want in the consumption layer it to be male, female, or other. That translation is really easy to do without programming in the MarkLogic world. So the ability to make data look the same is really easy, and it's part of the benefit we bring to the table. The other benefit is agility. So the ability to make that data look like tables, look like graphs, look like co-occurrence matrices, looks like geospatial data, and yet not having to change the data at all. Just look at it differently because you have a different index you can attach to it. That's one of the superpowers of this NoSQL Omni model database, because we're not talking about OmniRag today's verb or adjective. And so the next step along the puzzle was, okay, the user can ask a question, but how do we know what are the key concepts in the question? What's important? So I might say, hey, tell me about what are the side effects of Ozempic, right? Because that was a dinner conversation. um, and so in that question, side effects is a very important concept. Ozempic is an important concept, but what is Ozempic? Ozempic is a drug. So the concept that Ozempic is a subcategory of a drug, and what kind of a drug? Oh, it's a diet drug. Okay, so those sort of inherent knowledges in the concept of Ozempic are there, but they're not in the question, right? So one of the things we decided to do is just ask the large language model, the one that has the best understanding of the real world that we have access to, hey, please tell us what concepts are in here, right? And now we have those concepts, we can use those to help us find a better set of data that matches what was being asked. Because now we have a better understanding of the intent of the question that the user asked. So that's sort of a kind of a nice, easy way to take advantage of a large GenAI system without having to have it look at all your data. Basically, what we're saying is look at the question and tell us what's important in the question, right? So that's step 2. Step 3 is find that set of data. And now these GenAI systems have token windows. They have a small area of space to actually fit the data. So if I have a billion documents with 100 billion chunks, and it might be 100 terabytes of data, I'm not going to be able to provide all that 100 terabytes of data, but I shouldn't, because what I really want to do is find Ozempic related data, find side effect related data, and that's all I want to feed it. And if I can shrink the 100 terabytes of data down to 20 kilobytes of data, I've saved a lot of cost because I'm only feeding the GenAI 20 kilobytes worth of tokens instead of a much larger set of tokens, right? So that's one place to save costs. Then the GenAI does the answer, and the answer will be better because we're at least giving it some private data in this scenario. And I akin this to being an open book exam. In my college days, open book exams were only as good as the amount of review you did, because you needed to know which chapter, which page to go to answer which question. And if you didn't spend that time to figure out which page to get to, you were toast. It didn't matter whether you had the book with you or not, right? So this is the part that MarkLogic and the sort of combo GenAI system is now doing, is helping you get to the right page, right? So then we said, okay, we can do better than this. And so we thought about, okay, what if we were to sit my teaching assistant right next to me and allow me to have lifeline questions against it for the really hard questions, right? And that's what this next architecture was. It was basically, let's pair a graph or knowledge database with your content. And the graph and knowledge database can do a couple of things. One, when you bring the content in, you can tag the content and you can say this content is about, and I'm sure you've had the semaphore talks, is about this concept or these 10 concepts, right? And in fact, this subparagraph here is about this one particular concept. So you know how to hone in on various sections of your document very, very rapidly too. Then you have the ability to extract facts. If you have facts in a table, the ability to say, hey, like Dow was on our panel this morning, this chemical has this temperature melting point, and you better not exceed that in sort of normal day-to-day use, right? So the ability to extract that as a fact from a PDF document that was used for transitioning from, say, the manufacturing to the sales team would be a really interesting thing to do, and have the ability to query against that kind of what are the environmental factors that are allowed for this product, right? So those are the kinds of things that you can do to prepare the data for use, right? And then when you do that, you can also use the same knowledge graph to say what's important in the question, just like we did ask the GenAI. So now we have two ways of trying to figure out what's important. So that helps us with better relevancy when we find the data and return it back to the GenAI. Now, let's say you have 50 chunks of data that you're giving to the GenAI. And out of those 50 chunks, really your knowledge graph says there's only, let's say out of those 50 chunks, you have 5,000 sentences. There's only 300 sentences that match the knowledge of the enterprise that you want to use for this use case. Well, then why are you sending 5,000 sentences to the GenAI? Why not only send 300 sentences? Yet another way to really concentrate the context that you're feeding the Gen AI, right? Then when you get the answer, even in the answer, you can tell the Gen AI, if you used any of the data we gave you, please provide it as referential integrity link so that the end user can validate and check your answer. We can also not only have it come back and allow for links back to the data, but we can also have it allow links back to the graph and allow end users to explore the graph and go, oh, Ozempic is a dietary drug. Oh, what other dietary drugs are there? What are the other side effects? How do you compare efficacy for that for South Asian males, right? Like me with my tummy, right? You know, so there's things that now, because you have this graph, you can explore all sorts of things and become more efficient at asking the right questions that are relevant to you in particular. This was a study that Biju found and brought me to, and I was like, oh, this is really cool. So what is this? What are these lines? So this is a data set that Stanford put together. And Stanford basically, they had 20,000 questions, no, actually 40,000 questions and 20,000 paragraphs. And the way the data set is structured is only one paragraph can answer the question. So you can tell very readily if the system that you were asking the question of gave you the right paragraph back, right? And that's called recall. So did I get the right paragraph back? If you are only allowed one paragraph back, then that's this line right here. It doesn't really matter what tech you use. You're going to be wrong 1/3 of the time, right? Whether you're using search or vectors, in this particular case, these were the two that they compared. You're wrong 1/3 of the time because you didn't get the right paragraph back. On the other hand, if you go back to say 9 or 10, that's like the first page of Google, and now you're beginning to see a little bit of differentiation. You're seeing that, okay, search is maybe like 86, vectors are able to get you 87, but this orange line was interesting. It was like, hey, search followed by vector reordering or vector relevancy gets you 90%. So it's like, okay, aha. And intuitively it makes sense. If I have 10 tools or 10 different ways of finding data, if I can combine those for the right use cases, I can find the data better and I can get the right context better. And by getting the right context better, I can be more accurate. But 90% might not be good enough for some use cases, especially where legal liability or implications are involved, right? Or you're like the Canada Air chatbot that gave away a ticket, and Canada Air tried to fight it and said, that's not our chatbot. And the judge said, but it's on your site, right? So they were liable for it, right? So sometimes 90% is not good enough. So the question is, okay, you want to do better? Well, how you do better is knowledge graphs. That's how you get closer to 100%. Now, I'm not going to claim you're going to get to 100% because this is all probabilistic and language based and in sort of that world. But you can do way better than regular available technologies with customized knowledge graphs that understand your use cases. An example of that was, and this was pre-GenAI, one very large pharmaceutical company came to us and said, Imran, we want the drug product label, that really long, fine print, really thin paper thing that you get with every drug that nobody reads. We want to be able to answer questions from it. We want the answer to show up in the top 3 results, no matter how the question is asked, right? And we're like, yeah, sure, we'll take that on. And so if you think about it, that and they wanted basically a 100% recall rate in the top 3. So if you follow this line and come up here, you're like, okay, 80%, 83%. This tech is not gonna cut it, right? So we created a custom graph, and we were able to hit 100% in the top 3, and 90% of the time, the best answer was the top answer, right? And they weren't feeding it back to their consumers. They were feeding it to their customer service reps with the human in the loop to actually give the answer back because of the liability concerns they had, right? So let's talk a little bit about semantics and understanding and compression. I think of large language models as knowledge compression engines. So they, as far as I'm concerned, are kind of like the JPEGs of the image world, not a PNG. They're a JPEG, right? You can compress it and the stuff can still look great, but at a certain point when you start compressing it too much, all understanding sort of falls off the cliff. And this is a 38 megabyte image that was compressed 1600 to 1. And so this is not very easy to understand. When I put it into PowerPoint, PowerPoint said, this is a close up of a hand. I'm like, okay, sure, whatever, right? Then 800 to 1, it said, oh, this is a close up of a line. Same picture, but definitely a different sort of interpretation of what's coming out of it, right? Then I did 8 to 1, and it's like, oh, this is a body of water, right? And in particular, does somebody want to say what this is? Sunset or sunrise? Yes, in this case, it was a sunrise. But you're right there, right? And then if you look at the whole picture and get this whole context, right, you're like, okay, what is this thing down here? Anybody want to take a guess? Sorry? A boat, yes. So we got a boat here, and then this little curvy, light gray thing over here. A bridge. Yep. And so that's, with context and with a lesser amount of compression, you can see stuff and understand the real world that this is a representation of, right? So why did I do that? Well, this chart is an eyesore. This is some research we did. First 5 columns are OpenAI. Last one is Google Gemini. Really, I want you to just think about a couple of columns. One is the cost is a lot lower here because these are way smaller models. Cost is a lot higher here, and typically 2 or 3 orders of magnitude more expensive on the smarter models. And the compression ratio. So this is how many parameters did I use to represent 580 gigabytes of data? Well, it's a 1600 to 1 compression. So you can bet there is some serious knowledge loss from that 580 gigabytes of data that is represented in that smaller model, right? So really, all I want you to get is the stuff on the left-hand side has a much lower semantic understanding of the real world than the stuff on the right-hand side, right? And that's really the key sort of thing here. The other thing to understand is humans, as we had at the panel discussion this morning, in the loop are still extremely important for consequential decisions and the consequences of those decisions, right? So simple stuff, yeah, okay, you can have some decisions made, but stuff that has large consequences or legal obligations or liabilities, you want humans in the loop. So getting back to this architecture, every time I present this, people go, oh, great, but what about this graph? How do I make this graph, right? How do I get to that endpoint in that knowledge base faster, right? And so we started thinking a lot about this and have been working on this as well. And, at one level, the vector relevancy stuff gives you automated graphs. But again, they have a much lower understanding of the real world. At the other extreme, you have subject matter experts that can manually create the graph for you, which is intense, but represents the subject matter expert knowledge. But so sort of the next step on that is, well, we can open this up to all of our users and have a knowledge review tool and have them provide feedback and put that into a workflow and have your subject matter experts approve it. So now you're sourcing your data from your whole user community, which is a step in the right direction, right? Because it makes the subject matter experts more efficient. But then when GenAI hit the scene, we're like, now we can make the subject matter experts real cyborgs, right? And in fact, we've seen anecdotally between 10 and 50x improvement in the ability for people to create graphs, the subject matter experts, right? And on this side, sure, you can take your small text embedding models, and you can create text embeddings and meaning from the vectors. But again, remember these guys, they can't pass the SAT. These guys can potentially pass the bar exam, right? Or write PhD papers in the next 2 or 3 years, right? So you want to take advantage of as many AI systems as possible when you're building out your solution, right? And so that leads us to the combination of these two things will give you much better search and get you to that higher level of accuracy and reliability that you need in most of your sort of customer-facing legal obligation use cases, right? Then we said, okay, we already have this system. How can we improve it further? And how can we turbocharge what is missing from the graph? And so what we said, because we already had the user question in our system in the loop, the thought process is now, all right, let's just take that and check against the knowledge graph that you have. And if it doesn't exist, and guess what? We have this knowledge review tool API that we can automatically feed the suggestion into, right? So now the users of the system are helping feed the suggestions that the subject matter experts can review. So it really, really helps you understand what's missing from your knowledge graph and has the subject matter experts be able to input it in real time. The nice thing about this is you change this graph, instantly you start getting better answers. So the first user that asks a question for a missing concept, it goes in, then the subject matter expert goes, yeah, this is a good concept, or this is a good synonym, throw it in there. The very next user will see better answers right away, right? So it's a real-time way of improving the system. And this is essentially an AI human cyborg learning system is the way to think about it. And then we thought about another thing from a cost perspective. You know, we talked about that $130,000 for 4 or 5 terabytes of data. Well, the question we asked was, if your users are only interested in 10% of your data, why are you vectorizing the rest of it? Now, this only works if you have a data platform that can get you into the ballpark, right? So if you have a multi-model, omni way of finding your data, then you bring that data back and you only vectorize the stuff that's in that user's query of interest. So if your users are only interested in 10% of your data, then you only vectorize 10% of your data, right? And that could cause significant order of magnitude cost savings for your company. Right. So we talked about how we're using semantic RAG to reduce risk and increase business value. And now I'll hand it over to Biju to show you a demo of all 3 architectures.
Thank you. So now let's see some of these things in action. So the demo will show about how knowledge retrieval is being done and how and about the data availability and the security aspects of it. So we have a demo application that is built. This is again built using Progress Kendo UI components. We have uploaded some documents already into the system. So let me log into the system first. And we have a chat interface, which is again comes with the Kendo UI. So we have like 2 ways of doing it. One is the chat style and one is the QA style. So I will start with the QA style, and if time permits, I will go to the chat style as well. There are 3 sections over here. So this is the closed book exam that Imran was talking about. This is the open book exam, and the last one is the open book with expert help. Okay, and so I'm going to start with a question. So I'm going to ask, can you provide an example where MarkLogic was used for digital twins? So the expectation here is the system goes against the MarkLogic use cases which are uploaded, and then it reads from that and gives me the right answer. Okay, so let me, and this is a public document so that we can use it in sessions like this as well. And behind the scene, what's happening is it is performing all the searches, tokenization, and everything, and it is making 3 different calls to the OpenAI, Azure OpenAI in the backend. And as I said, it is public information. So the closed book is also giving some answer. The open book, both the open book styles are also giving the answer. And if you look at it, they essentially talk about Boeing, MBSC, UIM platforms actually. So that is the right answer because MarkLogic digital twins, MarkLogic is being used by Boeing for the digital twin implementation. But if you look at it, the sources, which is very important from a RAG perspective, the traceability to, okay, where this is response coming from. I'm pretty certain that this is a made up link. It's not going to show anything. It is just redirecting to the MarkLogic homepage. Okay. When it comes to here, it shows the chunk from it is coming in, and again, if you there's a link directly to the actual use case document, which shows that actually how MarkLogic was used to enable digital twin in Boeing. Okay, and if you look at it here, the MarkLogic multimodal database is also being used because the chunks, the responses, the prompt, and the actual binary, everything is stored in MarkLogic. So as Imran was mentioning, you store anything and you access the way that you want it, actually, right? In the JSON format, in its raw format, or and things like that. So here the answer will not be any different. It is just the text is different because it is two different calls. So OpenAI gave a different text of it, actually, but essentially meaning the same thing, right? Now let me slightly twist the question. Right, I'm going to ask, can you provide an example where MarkLogic was used for device shadows? The device shadows is maybe a less known synonym for digital twin. It could be like cyber models or cyber shadows and stuff like that as well. But the way I want you to think about it is actually it is your private data, right? Something that your department uses, but your department uses that term, but your company is not using that term across, right? So what happens when you use your private term in a query, right? Let's see what happens now. And the time it takes is because the three different calls and things like that. And it says the first one, I'm unsure, it doesn't know. The second one, again, based on the provider documents, which is the private document that we have sent, again, the open book exam didn't understand, but the expert help exam understood the answer, right? It again saying about UAM and Boeing and things like that. So how it is happening, right? So again, it is referring to the same document. Right, it is referring to the same document, it is answering it. And that is because of the knowledge graph that is helping this query, where we are saying that actually, okay, when you are evaluating this query, device shadow should be considered as a synonym or an alternate label, because this is what my department uses. So use that as a synonym for a digital twin, and that is where it is happening, right? So as a UI tidbit, actually what we have is like the user can select the right answer. So maybe he can do like this, right? And this can be recorded again back to MarkLogic, because MarkLogic is a transactional operational database as well. So you record these responses on the system, and then say that actually, okay, how can you improve it later, right? So tomorrow, if this question is not responding, and you expect the right response, you can mark it as red, or you want to improve this response further, and then somebody can look at it, all the red marked ones, the unaccepted ones, and improve the system, right? Another capability, again, highlighting the multimodal feature, is we store the response, the prompt that was used, everything in its raw format in MarkLogic itself. So basically, this is essentially saying that, okay, what was the question that was asked, and what time it was answer was produced, then what is the response that is got generated, what are the sources, what was used. So basically this is the automated semantics part, where we are saying that actually the prompted label from the query was device shadows. But then we are saying that the prompted alt labels were all these things, right? All the other labels that are synonyms to device shadows. And then what are the document URIs that search produced? And this is where actually the real situation of not sending all the documents, but only the most relevant documents into the GenAI system. And then we have the actual prompt. So you have full traceability that is there, and which model was used and which user used, right? So everything is included, and this is stored in MarkLogic itself. You can generate analytics out of it. You can use it for fine tuning the results and things like that, right? Now, I will quickly go to the security part of it actually. So I'm going to use another user, MarkLogic Public Reader. And let me log into the system. And I typed it wrong. Okay, I'm going to ask the same question. Maybe let me ask the digital twins question, right? So here, what I'm going to showcase is basically like the other user, the all reader user had access to all the documents that I have uploaded. But this user does not have access to. So at the time of loading the document, I have associated roles with the document and saying that actually this user is not able to read the use case documents. Okay, so now it is unable to answer again. This one does not use any private data, so it is using from its public information. But both the other exams failed on it because
I can't read the question.
It's the same question. Can you provide an example where MarkLogic was used for digital twins? Okay, it's the same question that was used, but it is unable to answer it because the documents are not read. So it is as good as you do not provide that those documents to the LLM, right? But again, MarkLogic security is applied on the data, not on the middle tier, not on the premises, right? It is on the data. So yeah, that's about the demo. Then questions for both of us, actually.
Yeah, actually, let's flip back to the slides. I want to bring up just a couple more slides. So this is just an example of the knowledge graph that we have. If you click on the digital twins one, then you can see that down here, here's the alternative labels that are known in the industry or so on in your department, for example. And device shadows was one of them, and that's why we were able to help answer that question, right? And then, so this is just sort of the overall space of data itself is locked down with roles and security. And if you lock the data down, then the GenAI doesn't get the data and it won't answer because the user didn't have the rights to access that data, right? So because the data and the roles are tied tightly to each other, the security of your GenAI system just naturally flows from the security of the data. Okay, and yeah, all right, fair enough. We'll just leave it open for questions.
So you talked about strategies for increasing recall on, recall of finding documents from your indexes or from your data sources. What kind of strategies might you use if you were looking to increase precision rather than recall?
Right. On the precision side, I would say you can use the same graphs and the same data sets. The difference is how you construct the actual query in the from that you feed into the MarkLogic data platform, right? So if you're looking for recall, then you would kind of do OR against all the things you're looking for. If you're looking for precision, you might want to do OR against the concept labels, but and between the concepts, right? So, and MarkLogic allows you to do those kinds of things. So that would be totally tunable by your use case. Good question, Zach. Hang on, one over there. And then up front, we have a question too.
In terms of the system of both MarkLogic and Semaphore used here, it seems like they work together to produce an improvement in your total output, right? Or your accuracy of your output, correct?
Yes, there's a lot of synergies between the two systems, and the features and functions that exist in each of the products alone are great, but when you combine the two products, you get extra features and functions that are available just because the two are working together in tandem very tightly.
Would you ever use just one of the products?
If you're building out a system where the precision and the security are super high, then I would not recommend using just one of the products. If you're doing information retrieval, where it's okay to be wrong 1/3 of the time, yeah, you could probably get away with just your data sets.
So my question is, you have to load the data into the MarkLogic, or you have to integrate or like just plug into the different sources within the organization?
So we have multiple paradigms. The way I would think about what to load into the platform would be the same way you think about what Google does for the net. It doesn't load all of the data into its indexes. It just loads the stuff people are interested in finding, and the amount of data that and the linkages between those data sets that are important for helping prioritize relevancy and recall and precision, right? So what you need to put into MarkLogic is typically the metadata of your documents and files. But when I say metadata, I use that word loosely. I consider the text of the document metadata, right? But you don't actually have to store the full document in MarkLogic or the full database in MarkLogic. If there are certain columns in your database that are important for search and discovery, that data needs to show up in MarkLogic so that it's indexed and discoverable and searchable. The rest of the data you can leave in your original data set, right, if you want to.
So in the demo, actually, we are storing the binary, the original document also in MarkLogic. But if you really look at it, actually, on the way in, we are chunking the document after text extraction. And as part of that, actually, you can have your metadata link to maybe your SharePoint site or your Documentum site, actually, or you need not necessarily store that document in. But from a capability standpoint, MarkLogic can store binary documents as well. PDFs, images. One of our customers who implemented the same thing, the database will grow too big actually, and they didn't want to duplicate the original documents, so they could do it in that way as well.
Any other questions? Well, thank you very much for showing.